Okay, time for some probability. This is going to be chapter 13.1 in your books in case you wanted to do any work, follow along from your book, or get some extra help. Before we start, though, I would ask that you have a pen and paper handy. Pencil's okay, basically anything to write with. Take some short notes, nothing huge. Just something that you can look at to kind of remind you of things, use on a quiz. Also, there's going to be a few questions at the end, so I just won't take long. Just answer the questions as best you can, and if you've paid attention during the video, there shouldn't be any problem at all. Alright, so that being said, let's get started. And we will start off with some vocabulary, just so that you understand, or at least are kind of have an idea as to what the difference between probability and odds are. Now, probability is the probability of an event is a measure of the likelihood or chance that the event will occur. This is a little bit different than odds. They're similar, but they are not the same. Odds, however, the odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. Okay, so that one was a little wordy, but if you see it, hopefully you'll understand a little bit better. So let's start off with probability. We're going to do an example here. You have a bag of marbles containing 4 red marbles, 3 green marbles, and 7 blue marbles. What is the probability of getting a blue marble? The first thing you want to do when you're figuring out probability is to find out your total number of objects. In this case, it's marbles. So how many marbles are there total? We have 4 red ones, 3 green ones, and 7 blue ones. So you've got 4 plus 3 plus 7. It's 14 marbles. Now 14 is our total number of outcomes, meaning that's every possible outcome of drawing a marble from the bag. Okay? So then the next thing that you need to find is how many blue marbles there are. Now we're looking for how many blue marbles there are because the question is, what is the probability of getting a blue marble? So whatever it is that you're trying to find, you want to find the number of that's given in the problem. In this case, 7. And we're going to call that the number of favorable outcomes. Alright, now what do you do once you have this information? You're going to go ahead and you're going to write it as a fraction. Okay? The number of favorable outcomes is going to be your numerator. In this case, it was 7. And then for the denominator, it's going to be the total number of outcomes. And in this case, 14. Now notice I said it's going to be a fraction, which means that if you can, I want you to reduce. So 7 over 14 reduces to 1 over 2. So you have about a 1 in 2 chance of drawing a blue marble from the bag. Okay, and that's the answer. That's all there is to it. So I'm going to have you do a few on your own. Here's the problem. If you had a bag filled with the letters that make up the word algebra, so think like Scrabble tiles, 1 letter per tile. What is the likelihood of drawing an R? First question. Second question, likelihood of drawing an A. And finally, what's the likelihood of drawing a T? I'd like you to pause the video here. Just take a minute, figure it out as best you can. When you've either finished or you've gotten to the point where you can't figure it out anymore, go ahead and start the video back up and let's walk through this. Alright, so remember what I said. The first thing you want to do is figure out the total number of possible outcomes. In this case, we've got 1, 2, 3, 4, 5, 6, 7 letters. So that's our total number of outcomes. Total number of outcomes. Alright, and let's see what they're asking. The likelihood of drawing an R. Well, in algebra, there's only one letter that is an R. So we're going to say that's the number of favorable outcomes. Okay? So your answer is just 1 over 7. You can't reduce it anymore, so you're good. Okay? Hopefully you're starting to get it. Now what's the likelihood of drawing an A? Well, our total number of outcomes hasn't changed. It's still 7. However, now there are 2 A's in algebra. So your answer is 2 over 7. Again, you can't reduce it, so it's just 2 over 7. And last, the probability of drawing a T. Well, there are no T's in algebra. There are still 7 letters, though. So the probability of drawing a T would be 0 out of 7, and we all know that 0 over any number, or 0 divided by any number, is just 0. So there's 0 probability of drawing a T. Yes, you can have 0 probability. In fact, I want you to keep that in the back of your mind. If you're taking notes, I would write that down. Okay, just so that you can refer back to it. Hopefully you get it. If not, if you still have some questions on probability, feel free to give me a holler tomorrow during class, and we'll see if we can get it straightened out for you. But moving on, now we're going to talk about odds. So our sample problem here, we have a study that indicates that out of every 60 telephone calls, 6 result in busy signals and 12 result in no answer. So what are the odds in favor of someone answering? Here's where odds and probability kind of diverge a little bit. Look at the information they have and look at what they're asking for. They're asking for the odds in favor of someone answering. Okay, what do we know? We know that 6 calls result in busy signals. We know that 12 go unanswered. And we know there are 60 total. Okay, so what are the number of calls that do get answered? Well, if you take the total, which is 60, and you subtract 12 and 6 from it, that's going to leave you with 42 that we're going to assume are answered. So we've got 42 answered calls. So where the fractions or the equations, however you want to look at it, differ is with odds, they're asking for the number of favorable outcomes, the odds in favor of someone answering. So the favorable outcomes are going to go on top. And underneath are going to be the number of unfavorable outcomes. So before, with probability, we had the total number of outcomes. Now we've got favorable versus unfavorable. Basically, when you add the top and bottom, most of the time, it should come out to be whatever your total is. So our number of favorable outcomes are the ones that are answered, so we're going to say that that's 42. And the number of unfavorable, well, 60 minus 42 is 18. Another way that you can think of to get that is 6 busy and 12 unanswered is 18 when you add it together. Okay, if it's busy, it's not answered, and if it's unanswered, obviously it's not answered. So you still count the busy signal ones. Now, can you reduce 42 over 18? Yes. 7 goes into both of those. 7 goes into 42, or I'm sorry, not 7, 6. 6 goes into both of these. 6 goes into 42 7 times, and 6 goes into 18 3 times. So again, you're going to write it as a fraction, 7 over 3. If you can reduce it like we did here. The difference is you can also write odds as a ratio and say 7 to 3. So there's 7 to 3 odds that someone will answer the phone. Okay? Hopefully you understand that, because we're going to go ahead and give you a chance to show off what you know. So you're going to try these on your own using the previous example, and I'll put that information up there for you again. There were 6 busy signals, 12 unanswered calls, 42 answered calls, and 60 total calls. So using that information, what are the odds against someone answering the phone? Okay, now be careful there, because it says the odds against. So what I will say is, if the odds for answering were 42 as far as favorable outcomes, what are the odds against that? So I want you to just think about that. Don't rush through it. Think about it again. Pause the video when I'm done here. Take a minute, try and figure it out, and then press play, and we'll see if you got it right. The second question, which should be a fairly easy one after that, is what are the odds in favor of getting a busy signal? So go ahead and pause it here. Take a minute, see what you can do. Okay, now you may have noticed that this one is similar to the last problem, okay, in the sense that you've got 42 in the problem because we're looking for someone answering the phone, but we're looking for the odds against that. So if the odds were for 42 over 18, the odds against would be 18 over 42. Okay, you see the difference? And again, it still reduces. 6 goes into both of them. And where this is different is that we're going to say it's 3 to 7 odds against someone answering the phone. Okay? So a little bit tricky, but if you're careful, you should catch it and it shouldn't be a problem. And last but not least, what are the odds in favor of getting a busy signal? Well, there were 6 busy signals, which leaves 12 and 42, which is 54. 54 cases where there was not a busy signal. Can you reduce 6 over 54? 6 goes into both of them. So 6 goes into 6 once and into 54 9 times. So your answer would be that. Okay, you have a 1 to 9 odds of getting a busy signal. Alright, so here were the infamous questions I was talking about. On a separate sheet of paper or on the paper with your notes, that's fine. I'm not going to collect it, so you can keep that for yourself. This is more for kind of reflection on the video. Question 1, I want you to write down what is the difference between probability and odds. I'm not looking for much more than a sentence or two, just a quick, concise explanation as to what the difference is. For the second question, how do you find the probability of an event occurring? You can use the fraction, the generalized fraction, or the formula, whatever you want to call it, to answer that question if you like. And then how do you determine the odds in favor of an event occurring? So kind of the same thing as the last problem. So just go ahead and answer those 3 questions. I'll be checking those the next time I see you in class. And if after doing that you have any more questions, just feel free to let me know. Okay? Have a good one, and thank you.